Distech Controls connects people with intelligent building solutions through their forward-thinking technologies and services. They reshape the way people operate, work in, and experience spaces with advanced building automation solutions. They are at the forefront of smart building innovation, providing more sustainable, autonomous, and human buildings. I'm Ryan Sen, Vice President of International Sales here at Distech Controls. Thank you for joining us for today's session. I'd like to try to explain how autonomous buildings will allow you to enhance the value of your assets while optimizing its operational costs with Chris Vintner, Product Line Manager for Building Management Software at Distech Controls. Hello, Chris.
Right.
First, can you define for us what exactly is an autonomous building?
The concept of autonomous vehicles or self-driving cars, which aim to limit the need for human intervention to do their most common task, to get a person from point A to point B, is now well understood by everyone. Vehicles do this by taking advantage of technological developments in hardware and software to adapt automatically to their environment to deliver desired outcome to the passengers. This concept can be adapted to the world of buildings. The promise of an autonomous building is the same as it is with autonomous vehicles: to have a building that makes its own decisions in order to optimize the user's experience, energy consumption, and its maintenance over time.
Chris, that makes a lot of sense, but why is building autonomy so important?
Well, according to UNEP, the building sector represents 40% of global energy consumption. In the context of increasing scarcity of resources combined with even higher expectations from occupants, technology needs to be part of the solution. The concept of autonomous buildings, powered by the technologies proposed by Distech Controls, is fully in line with this goal to make buildings more efficient, attractive, and valuable, making buildings that not only self-adapt to the people and systems in the building, but also can react to demands from conditions or requirements external to the building systems.
Well, Chris, you mentioned that an autonomous building needs to respond to two major influences: that of the needs inside the building, but more broadly, its integration into the larger ecosystem. First, at the building level, how can we actually illustrate the impact of this technology in controlling operational costs?
Yeah, I think of autonomous building technology as an extension of the technological evolutions we've observed in building management over time. So we've seen the implementation of the basic thermostat that controls the temperature of a space, to programmable thermostats that control to a building's theoretical schedule of occupancy hours. And then we saw the addition of smart thermostats with motion sensors to act according to the real occupancy of spaces. Because we can only optimize what we can measure, autonomous buildings will integrate new sensors to collect precise information on the actual real use of spaces. It's then necessary to analyze this data, and autonomous buildings take advantage of this information and additionally learn from past experiences, allowing the buildings to make their own decisions to adapt to the preferences of the people and of the environment. And this increase in building intelligence allows for a reduction in resource requirements and therefore energy cost and operational expenses.
Chris, that makes a lot of sense, but the adaptation of this new technology in commercial buildings has traditionally lagged behind other sectors. Do you still feel that's the case, or has this been overcome?
Yeah, right, I would agree historically, but I think we've really reached a level of technology maturity in buildings to implement this today. For example, our clients often ask us for solutions to efficiently manage meeting rooms. A meeting room with the right sensors and the right software to count people accurately allows them to, depending on the number of people, decide how much fresh air to send in, to optimize the quality of the air, and to condition the air properly to maintain the proper comfort. The systems can also use this data to help owners adapt the layout of their building spaces based on the real use. The building can adapt cleaning needs to the actual usage and even reach outside the building to the cleaning service provider to request the room to be cleaned based on actual usage. This is the main difference between a smart building and an autonomous one. The autonomous building not only identifies the problem, but it can take action to solve it.
That's a great point, Chris. I mean, it's important to think not just in terms of the needs within the building, but also in terms of its integration into a larger network or ecosystem. What does Distech offer in terms of solutions that allow this level of connectivity?
Yeah, an autonomous building, like I said, must be able to be open and adaptable to the larger ecosystem. So it needs to speak to the smart grid, the smart city, CMMS systems, access control, room reservation systems, occupant applications, EV charging stations, the list can go on and on. Last year, Guidehouse Insights published an article that said this about the smart connected building: not one vendor is in a position to meet all the needs in a building. This reinforces even more that building openness and connectivity is paramount to the future of autonomous buildings. And that's why at Distech Controls, we strive to create products that are the most open, most connected, and most interoperable in the marketplace.
That is a key point. We have to look at buildings more holistically. Smart cities today are a collection of smart or autonomous buildings that are all connected to power plants and to a distribution network and eventually to a set of consumers. This technology offered by Distech controls allows us to create these links and interactions. For example, we can communicate with a set of electric vehicles connected to the building, which are both consumers and producers by returning unused energy during critical phases of the grid. Now, the openness of our solutions allow for the creation of powerful optimization scenarios. The interaction between systems can also allow building managers or the buildings themselves to facilitate maintenance actions, such as the replacement of defective equipment through a better knowledge of the actual building's operation. Chris, this discussion has been truly insightful. I really appreciate you spending some time with us today. Thanks again.
Thanks, Ryan.